My godfathers, what is he doing now, I hear you cry. Well, I feel a bit of a cheat because I haven't got anything physical to show, which is one of the issues with 3D printing. That you do it all, it's all virtual until you actually get around to printing anything. And because this head, Victoria, the new Automaton's head, is far more complicated and larger than Florence's was, it is taking ages and causing me lots of headaches. So I've got to the stage and I thought, I've got to make a video because otherwise I'm just going to carry on and never get round to it. And I'm going to forget how I've done things and what I've done. So the stage at the moment is, this fine morning with no rain at the moment, is that after much umming and ahhing, and this is the other problem with 3D printing, is you have no constraints really. If you can imagine it, it's probably possible to print it. So, with the aid of my pointy finger, this is going to be brass hex rod. I've finally decided how I'm going to, I've obviously not done the fun bit first, no. You know, like the eyes and the mouth. Oh no, start on the most complicated bit first. Oh dear, talk about work ethic. So I've been working on the way of getting her head to angle, look up and down in effect. In the end I've decided to go with the Frankenstein look, which I've got to work something out about. What's going to happen is, and there's these two colour heads, just so that while I'm working on this I can actually see the maximum minimum movement. So here, for example, let's get it in view, the pink one is with her looking up as high as possible to make sure this time, doing it properly, that when she's looking up there is room at the back, there's clearance for the neck to go inside. And the green one is when she's looking right down, and again there's clearance there, and I've worked out the position of the axle in the middle. What I was originally going to do was, and here's one I modelled earlier, one of these lovely little motors that I've witted on about before, and I might interject a little demonstration just to get out of the real world and back into, get into the real world and out of the virtual world. So that might appear in a minute. A quick impromptu explanation of how you can make machines turn, or your inventions. Like I said, there's the little mini stepper motor, and these always come, they're sold because, I'm saying they're mass produced for use in air conditioners and things. They come with their own version of this, the little driver board, because each of the coils, the 4 coils in the motor, the stepper motor inside, draws quite a lot of current, uses quite a lot of electricity. You need it, plugs into this, there's a circuit here, an integrated circuit that drives, that turns a very small voltage that you deliver from your Arduino or Raspberry Pi or something into a much larger current that can drive the motor. It also has 4 LEDs, which is useful, I assume, as an aid to servicing air conditioners and things, because if you can see, if these aren't flashing on and off, you know the problem lies somewhere this side of things. If they are flashing on and off and the motor isn't turning, you know it's on this side of things. So there's that, and there's the servo motor, which I just mentioned to you, and there's this amazing little thing. I think I'm zoomed in as much as I can. No, I'm not. These are absolutely incredible. You can get them, this is a miniature version, but you can get them in all sorts of different gear ratios. Beautiful little gears. I bought this because I was going to use it on something, and I can't remember what it was. I think it was the climatic revelator, when I was thinking about how I was going to drive it. The downside of these are, if I can switch a power supply on and switch this on, yeah, there we are. Beautiful. I was thinking I could put a magnifying glass over the little lenses so that you could see them all turning. So that's fantastic. And this is on 3 volts. It is it's geared down so much that I can't stop it. Downside is, as soon as you mount this on something, that happens, because the friction between all the gears creates lots of noise, and that's what stopped me from using it. Because the little motor at the back, this bit is whizzing around so fast you get to hear that. And I tried mounting them in sort of silicone rubber surrounds and on springs. Just no good. Not for things if you want them nice and quiet, which is a shame. Now, to demonstrate this little stepper motor, I have a bit of blue tack and a pair of tweezers that were handy, just stuck on the top so you can see it moving. I've got that plugged into the aforementioned interface, and I've got that connected up to an Arduino Uno, which I just think is fantastic. Let me explain why. Also, before I go on, I've got this connected up to the interface, connected up to a power supply, which is set at 5 volts. There we are, 5 volts. Simply because, like we said before, the stepper motor takes quite a lot of current, and the Arduino will be damaged trying to provide that much. So the Arduino runs the little interface board, and the interface board is connected to the power supply, so it just gets as much electricity as it needs to actually control the motor. Now, the fantastic thing, yes, another fantastic thing, if I move this a bit nearer about the Arduino, oh yeah, the Arduino. Right, this is the Arduino IED, which is the integrated IDE, no wonder I couldn't get it, IDE, Integrated Development Environment, and it's a bit of software, an application that you can download, and it's all free and everything else. It's absolutely fantastic, brilliant community developing and sharing, creating and everything with this. And you click on File, you can go to, oh, not that, Examples, and there's a lovely library called can't see that now, Excel Stepper. There it is. And you just click on Excel Stepper, and then it gives you all these examples. It is such a fantastic idea, because you need somewhere, some sort of starting point if you're going to start using stepper motors and don't know anything about them like I didn't. So, you know, there's one sort of bounce. So I just click on bounce, and it comes up. So you open that up, and then you can just run it. Upload it to your Arduino by clicking on the little thing, the little upload, so it compiles it, uploads it, and sends it through the USB wire, simply through the USB wire into the wonderful Arduino. Once you've uploaded a program into here, you don't have to. You can unplug the USB wire, and then every time you switch the power onto the Arduino, it will just carry out the instructions that it's got. So let's see. It's now uploaded it. Would you Adam and Eve it? There we are. So this is the bounce one. You can get lots and lots of other stepper motor driver libraries, but I do like this one simply because it's simply because it's got the acceleration. You can set how quickly you want it to accelerate and decelerate, which is perfect for sort of automatons and things and machines in general, because it decreases the amount of force that are applied to gears and things when it first starts moving. Just gently starts, gently slows down, which is fabulous. And the effect you get, as you can see, it speeds up, then moves around a set distance, and again that's really useful with stepper motors, being able to control precisely where they point. Because you can count round, in effect 64 of these little separate steps will do a full rotation, so you can very accurately work out exactly where it's got to go. In fact, I think it's more than 64. Oh, I can't remember. It's a lot anyway. So that's the stepper motor. Thing is that the Arduino doesn't have a clue where this is. It's so easy to forget that. Oh, and before I say that, libraries. Now, there are lots and lots of very kind people in the Arduino community who will write a piece of code to do a job, like run this stepper motor, and they will then wrap it up or create it, convert it into a library. And the libraries are free to download. There's tons of them, things, anything you can imagine. Someone's written a library for you. You just download it, very easy to put into Arduino, and then you can use it. I mean, with this one, you have an include, and then you include the Arduino, the IDE will automatically do this. You can say, "Oh, just include this library, I want to use it," and it will write this piece of code for you. Excel stepper H library. Then you can define it, call it what you want, tell it which pins are connected to what, and then you can control it. Now this is, as I said, an example that the libraries come with, which is fabulous. It's so good that they come with working examples. Then you look at this and you can figure it out and you can change it and you can get it to do what you want. So that's great. One very important thing is to let the Arduino know where this is, because it needs to point. For example, with Florence, when I switched it on, I needed to know that the motor that controlled Florence's neck, which whether she faced right or left, was right in the centre. And you do that by adding a sense to the circuits of feedback. And the easiest way of doing that is to either, well, to use some sort of switch with motors. So you could have a little micro switch like this. Let's put it on autofocus. Here's a little micro switch, a miniature one. And they have a lever usually on the top, and it doesn't take much force, but they have a really good mechanism inside that millions and millions of times will work perfectly, very little force. So on Florence there's one of those at the back, and when you first switch her on, the Arduino tells her to turn left and keep going left until the switch clicks, she's hit it. Then it knows where she is, so then it can say, okay, turn however many steps back to face the front. So there's that. Or if you don't want it to stop and want it to keep going round and round and round, like with the barometric prognosticator, where there's one of these stepper motors turning the readings dial and also controlling the pitch of the flute, you can use one of these reed switches. And you can see how small they are. You can get them larger and smaller than this, and I can't zoom in anymore because it'll go out of focus, unfortunately. I'll need to invest in a better lens, I think. You have a little magnet, very small magnet, fixed onto, say, the end of these tweezers, and underneath, or hidden away somewhere, you have a little reed switch. And then as this passes, it switches the reed switch on. And then you can use that connected to the Arduino, another pin on the Arduino, to say, okay, I'm here, set everything to 0, I now know where I am. I was going to wire all these up and show you, but I'm now aware, I've started speaking with only the dog to keep entertained and my own voices in my head. I can't stop speaking. I must stop. Perhaps I will just wire up one last thing before I stop speaking, otherwise this video is going to become my life story, which I wouldn't inflict on anyone. I will connect this up to another library and show you that working, show you the difference. So I've connected the servo, so what I do is I go to File, Examples, and go down to Servo. And there's two options, one controlling it with a knob or another one sweeping it backwards and forwards. So I'm going to click on Sweep, and here it is. Isn't that incredible? And it says attach the servo control wire to pin 9, which I've done, and then just click on compile and upload. There's the servo motor, and it's 3 wires. Again, because servo motors use quite a lot of electricity, the Arduino will be damaged trying to run it off that. So if you can see around all the spaghetti and stuff, all you do with a servo motor is you have positive supply voltage 5 volts, which I'm supplying again from the power supply, so it's not taking any electricity out of the Arduino, so to speak. I've got 0 volts coming along to 0 volts on the Arduino and 0 volts to the servo motor, and I've got the signal wire from the servo motor, which is the yellow wire here, going to number 9. And they're the only connections you need. The power supply, the power for the Arduino is actually coming from the USB wire at the moment. That's absolutely fine. So it's uploaded now, so let's switch it on and see what it does. So the example, the sweep example, sends it right around one way and then back the other way. And you can see there's no control over speed. The only way you can control the speed of a stepper motor, like a servo motor, is to pulse it. Just tell it move around a little bit. But that, you can see the jerks, and like I said before, it does put quite a lot of force on all the gears and mechanisms. So very useful for some things, little things, although these have got an awful lot of force. I don't know what this one says, how many Newton meters it is, but they are very tough, and the better, good quality ones have real ball bearings in them, metal gears. So, and I was thinking, wow, let's keep this simple, because we're so good at keeping things simple. Have one of those here, possibly one both sides, directly linked, fixed to the neck and linked to the head. And then you can use the bearings in the motors, and you can use both motors one wide backwards so they turn the head. Oh, I can't even remember, sleepless nights and all the rest of it, trying to figure out this, that and the other, and I think I decided it's not worth it. This has to be designed, if it's going to be used in bars, restaurants, libraries and all the rest of it, hopefully as a marketable product, it needs to be 100% reliable, or as near to that as I can get it. Obviously nothing is 100%. So in the end, you know, I bought some bearings, and I've got some of this brass hex rod. The good thing about using this hex rod is it grips. If you mould this shape, the hex shape in the head, and in a gear that's going to go on here, you know that it can't slip. If you remember back to Florence, she was quite lumpy, and as someone very kindly pointed out, there's an amazing piece of software. Well, it is absolutely incredible. Very, very difficult to use. Talk about, well, it's just too complicated for intuition. This is nice, 3D Builder, because it's for children and for me, because I don't have to read any instructions. And like old dogs and new tricks and all that, I've found it fairly easy to come to terms with. But let's have a look at the software called Blender. You can see, if we zoom in, all the facets on her head. And like I said in the last video, I don't want her looking like Crichton from Red Dwarf, so I want to smooth that out. And there is a fabulous tool somewhere or other, I think actually it's under here, Add Modifier. Oh, it just does so much, it's crazy. But it smooths it out and breaks each one up into more surfaces, which is great. So having spent an awful long time working on that, and then filled in the eyes and mouth and stuff, because that's one thing that 3D Builder doesn't like, and imported her into that. And that is an extremely long story cut short. The other thing I've been working on is, here we are, let's zoom out a little bit. This is the neck. And the lovely thing about Blender is, because you can move and select individual points on the wire mesh, so I mean I can show you the wire mesh wireframe, there we are. There's all the little separate bits that go to make up, each one being flat, and then there's lots of them so you don't notice that they're flat. And they're all the little shapes that go into making up the overall look of it. I can't remember what I was going to say. Oh, the good thing about Blender is that things like the neck, with this one you can, what am I pressing? With 3D Builder you can cut things and stretch things and stuff, like extrude things, and that's great, but they stay with the same outside circumference or outside shape. Whereas with Blender I was able to stretch the neck down and carry on increasing the shape of it and everything, which is lovely. The other thing I've been looking at is the bearing. I don't know why I'm getting so completely confused by this. I think because I'm working in a virtual world, everything is open to so many possibilities. The limitations are not there because I've not got two lumps of metal that I have to stick together and there's a couple of ways of doing it. It's just too much choice. I think that's what the problem is. But I've found some Lazy Susan bearings. In fact, I will show them. This is the version I used for Florence. And, ooh, It's pressed metal and it's square obviously, which didn't matter because I hid it down underneath Florence. Between the two metal plates there are a row of ball bearings, or a circle even of ball bearings fixed between the two. Well, I might use a pointer, there we are, fixed between this bit. They run round in there, it's hooked over and fixed underneath, so they won't pull apart. And if you push down on it, as you would with a Lazy Susan, it's fine, there's very low friction. But I noticed with Florence that obviously you can't pull it up. If you pull it up at all, rocking from side to side, then you just have the friction between the two metal pressed surfaces. So that was no good. So let's have a look at another one I found, which I have, here we are. So it looks like that, and it's made of aluminium alloy, and you can just see a few of the ball bearing, the balls, steel balls in there. And with these bearings, there's a rounded slot in the middle bit in the centre and in the outside bit, so the balls are captive within, between the inside and outside. That means that the bearings, the balls hold them together, so you can push force downwards, you can push force upwards, you still have very low friction. There's another drawing. So that's my current plan, and these are 140. They come in all sorts of different sizes. They're brilliant things. As always, you have to spend hours looking past all the lying Google adverts and say, oh yeah, they're only £3.50 and no delivery, and then you look it up and suddenly they've gone up to 18 quid. Ridiculous. Yeah. Here's the whole range. Look at that. You can get, there's the one I'm going to get. Teachy little one, 140mm across. But look at the size of that. If I was going to build a huge Gregorian scribulator, I would definitely use this to support the drawing disc. It would be amazing. So any of you who like or want to build exciting things and need a large bearing, don't even look up ball bearings and large, because you will pay an absolute fortune. And here is a picture of a Lazy Susan in all its glory. I've got to show you this, it's just incredible, it really is. I will click on this head and I'm going to subtract this head from anything that it goes through using the subtract button. Look at that, isn't that incredible? So what it's done, it's mind-blowing, it's so clever. So here we are, look, this is the bit of this extra part that was through the head. I've now deleted it. It's deleted wherever it passed through the head. So what I can do now is remove everything. I don't want this bit because that's the bit that's stuck on the outside, so I'll delete that. I don't know what that little bit is, but I don't want it, so I'll delete that. I just want this bit. As you can see there, I've got this new piece in here. I made it a little bit long. It's going to be annoying because it's going to bang into that. So what I can do is to bring it over, just line it up. So there we are, you can see it's just lined up flush with the inside, just flush with the inside of the head. And here, ladies and gentlemen, there's a piece of the 1/4 inch, obviously, you know, got it off eBay some time ago and I just want to use what I've got. So this is great. And what I did, I measured it, as is my wont, and got one of these bearings which I had. If I can zoom in, come on bearing, there we are. Got one of these bearings which I got from Technobots online, which are a very reasonably priced place to get bearings. I wanted one with a large middle bit because I wanted to print an insert like so. You see, this is a bit crumbly at the back, but I don't care about that. And that fits perfectly in there, and then that in turn fits perfectly within the bearings. And now I've got a really nice way of supporting the end of the brass, and using bearings means that friction will be kept at an absolute minimum. This is going to support the head against the neck. And then I printed this little bit just to get the diameters right, because 3D printing doesn't come out exactly the right diameter that you've asked it to. So let's put that in now. Then you can see the cunning plan. That just pushes beautifully in there. And then this brass bar can continue through that. But that, wasn't it focus? But that's perfect now. Well, the other thing I've been working on, or I forget, from previous videos, it's the dog yawning, previous videos, you may remember that my wife kindly made a kraken out of clay, which I then sprayed up and used photogrammetry, which is not a huge learning curve, to turn it into a file on the computer that I could then print. And I did some experiments with metallic fibre for the 3D printer, and it just looks incredible. Absolutely amazing, because once it's scanned in, you can print little ones, or big ones, and little ones, excuse me, I just need to let the dog out. Right, dog's having its constitutional. It is amazing, this stuff. It looks like velvet or silk. And I designed them, I had some little red glass beads, marbles, so I designed these two simply so that the eye sockets would be the right size to push them in, and they look lovely. I took them to Whitby, and people showed lots of interest but didn't buy them, and I think I realised that it's because they hadn't got a purpose. So what I've gone and done is I've ordered some of these hair clips, apparently, not something I'd know about, and I'm going to design a bigger, better one possibly, or change it a bit so that these hair clip will fit underneath, because they look lovely in people's hair. In fact, I might nail one onto my head, walk around proudly with it. Also, some of these little pin things, which are good brooches. There's the front bit that you fix onto what you want to pin, like the kraken, and then there's a little butterfly thing at the back that pushes on and holds it in place. So I've got some of these. I've now got the Blender software, which allows me to fiddle and fart about with individual points. So that's all very exciting. So that's in the process of being sorted out. Once I've sorted this out, I will then put them on the website and Etsy page. So that's, remember, steamhead.co.uk, online shop for sales in the UK, because PayPal stupidly doesn't support international sales. Or Etsy, which is Steamhead Inventions, my Etsy shop, and they do support international sales because that's the Etsy payment system. And here's the beautiful dog who wants her lunch. And I've been making lots more kits. I'm thrilled to bits that the gauge kits are so popular. Denmark, I sent one to. France, Italy, US of A. It's amazing. Fantastic, and loads to this country. I'm so pleased. Thank you so much for watching, and I look forward to having something possibly a little bit more tangible to show you next time.